What's up, 20-1s? In this lesson, we're going to start working on solving quadratics. Up until this point, all we've been doing is looking at the graphs and analyzing these functions. But now we're going to start solving so we can answer math's greatest question, right? What is x? So how can we solve? Well, to solve, we can't have a function. We have to have an equation. And the difference between a function and an equation is simply this bad boy, an equal sign. Now that we have that, now we can find the solution or the roots, which are the x-intercepts of the corresponding function. Now, over the next few lessons, we'll learn several ways to do this algebraically, but today we're going to keep it simple. We're going to do it graphically. And I want you to think, graphing is easy, and this is how you're going to check your work every time I ask you to do it algebraically. So I've got a Slurpee, and I must not be happy because I'm going to take this thing, I'm going to launch it into the air, and it takes that path, negative 4.9 t squared plus 12t plus 10, where h is height in meters above ground and t is time in seconds that this Slurpee is in the air. Okay, we're using our calculator for all of this. Go grab your graphing calculator, and let's put this function in. So I'll pull up my calculator here. And I've got it in Y6 just for giggles because I wanted my Slurpee to be Orange Crush flavored orange. And so I've got that in. And now all we do is we hit graph. But when I hit graph, that's not the best graph in the world because it doesn't make sense in the context of the question. So let's change our window settings. So go to window. Okay, what is x? Well, x is time in this question. So the smallest amount of time I can have is 0. Now, x max, I'll leave at 10 because it looked like I saw the x-intercept I was looking for. Scale of 1 is fine. Okay, y. Well, y in this question is height. Well, the smallest height above ground I can be is 0, right? My Slurpee is going to hit the ground and explode. Now, the biggest, the maximum, I don't know. I didn't see it when I had that original graph. So I'm just going to go maybe up to 20. And I'll make my scale bigger, like 5. Now, I don't know if that's perfect or not. I don't know until I hit graph, but hey, that's a nice looking graph. Now that we've got that graph, look at everything we can find. We can find the max. We can find the y-intercept. We can find the x-intercepts. We can find everything here. So let's go ahead and do that. So let's find the maximum first. What's the maximum height this Slurpee gets at? Okay, so to find the max, I go second, calc, max, and it says left bound, right bound. So I just got to find my cursor, and I just got to hold down my left button a few times. And it should come flying up here in a second. There it is. Okay, so left bound, I got to get to the left side of the vertex, right about there. And then right bound, so I move to the other side, right about there, and hit enter. And guess, there it is. Our maximum height is 17.4 meters. I got a good arm on me when I'm throwing a Slurpee. Well, what's the 1.22? Well, the 1.22 is the time it takes to reach that maximum height. Okay, so let's go and answer some questions here. So the max height, we said, we already found, that was 17.3 meters. How long does it take for the Slurpee to reach the max height? I'm kind of going a little out of order here, friends. Sorry about that, but the max height was 17.3 meters and it took 1.2 seconds to get there. Okay, so usually finding the vertex is a key part of these questions. That's where I started. Okay, number 1 says, what is the time the Slurpee spends in the air? And number 3 says, what height did I launch this thing from? Okay, let's go back to our calculators and let's see how we solve these. So how long was it in the air? Well, to find how long it was in the air, that means I want to find that positive x-intercept. Again, there's more than one way to do this, but what I think is the easiest way on a TI is to let another y value equal 0. And then it draws it in. You see now my x-axis is blue because now I'm going to find where these two graphs cross or intersect. So first curve, enter, second curve, enter, guess, who cares, enter. Look at that. It took 3.1 seconds for this thing to hit the ground and explode in a slurpy mess. Now, what height did I launch it from? Well, I launched it from a height when time was 0. That's when it was in my hands. So I'm going to go second, calc, value, 0, enter. Oh, I'm on the wrong line. I'm just going to hit my up arrow, and there it is on my orange graph. My orange crust Slurpee left my hands at a height of 10 meters. So I'm clearly on top of a building. I'm on top of the school, throwing Slurpees off the school or something. It's what I like to do in my spare time. So what is the time spent in the air? Well, we said 3.1 seconds. Again, that was our positive x-intercept. At what height is the Slurpee thrown from? Well, 10 meters. That's our y-intercept. It's also then our constant term in the function, isn't it? So there's 4 decent questions, which we'll learn how to do algebraically in another lesson. Okay, 5 is how long is the Slurpee above 10 meters? Okay, let's go back to our graphing calculator. How long is it above 10 meters? So what I'm going to do is that's a y value. So I'm going to let y equal 10 and hit graph. So it's above between the 2 points of intersection. Well, it starts at 10 meters, so I got to go find that other point of intersection. So second calc intersect and enter, enter, enter. So it intersects again on the way back down at about 2.45 seconds. So how long was this Slurpee above that height? Well, it was above for 2.45 seconds. Okay, that's a good thing. So this is a very, very common question here about how long is it above. So what we did again here was we let a different y value equal 10, and we found that point of intersection, and we said it was about 2.45 seconds. Okay, last question. What are the restrictions on this function? Well, the restrictions are simply what I want you to think. It's where I drew my Slurpee, right? Like, it didn't make sense to see that whole graph. So the restrictions, or really what I'm asking is, what's the domain of this thing? Well, domain is time in this case, so t such that time started at 0, and how long was that thing in the air? How long until it hit the ground? It hit the ground after 3.1 seconds. Time is an element of the reals. Okay, the range or the height is started at 0 and it went up to a max height of 17.3 meters. H is an element of the reals. So there, friends, I mean, that's how you solve these functions using your graphing calculator. It's really basic stuff. That being said, solving algebraically, of course, is going to be a little bit more difficult. See you in another video.